Hi everybody, today we are going to learn how to graph a line using what's called slope-intercept form. So slope-intercept form is perhaps one of our most important equations involving linear functions. So this is slope-intercept form, y equals mx plus b. So anytime we want to graph a line, this is going to be the easiest way for us to graph it. So you'll notice that there's two variables that we don't know. There's m and there's b. So these are really all you need to be able to graph a line. So let's start with m. M, the coefficient of x, represents the slope of your line, which remember is rise over run. So if you can find the x value, look at the coefficient. That's just the number in front of x, and that is the value of your slope. So we're going to use that to help us know, oh, which way should I move on my graph? But we need a starting point. So this b value is going to help us with our starting point. So this b value is our y-intercept. And that's why they call it slope-intercept form, because those are the two things we can tell by looking at it. So the y-intercept is where your line crosses your y-axis. So remember, your y-axis is the vertical axis. So for example, if you had a line like this, the y-intercept is this point. So since it is a point on your graph, we're always going to write it as a coordinate. So it's always going to be 0 and then whatever that b value is, because the y-intercept will always occur when x is 0. So we're going to need to make sure we're very clear that our y-intercept is a coordinate. So if you can find the slope and the y-intercept of your line, you can graph any linear equation very, very quickly. All right, let's give these a try. So here you're asked to determine the y-intercept and slope and then graph. So we're going to be writing this out for every single problem. So let's start with this first one. Remember that our slope-intercept form looks like this. I'll write it at the top. Y equals mx plus b. So I'm going to look at my equation, which is y equals x, and I'm going to try to match up the parts. So let's start with the m value. Remember, m is the coefficient of x. Well, if I look at this, I can see that the coefficient of x is actually 1. So look at it and ask yourself, how many x's do you see? 1. So m is 1. However, I'm going to write that as 1 over 1. Any whole number, let's write it as a fraction so you have rise and run. So remember, the top number is always going to tell you how much you should move up or down. In this case, since it's positive, it's telling us to move up 1. The bottom number, the denominator, tells you horizontal movement, and it's telling us to go to the right one because it's also positive. So this slope tells us how to move from one point to the next. We go up 1, right 1. Now we need to have a starting point. So we're going to look for some number added or subtracted at the end. So if you look, you'll notice that there is no number added or subtracted at the end, or at least we don't see it. That means our b value is actually 0. So our y-intercept is at 0, 0. It's at the origin. So let's graph this line. We always start with the y-intercept because we need somewhere to start, and then we just follow what our slope is telling us to do. Up 1, right 1, and then we make a point. Up 1, right 1, make a point. And you can continue that pattern for as far as your graph allows. Now notice we only have points on this side, so to find points on the left side, we're just going to go backwards. Instead of going up 1, right 1, we'll go down 1, left 1. Down 1, left 1, down 1, left 1, for as far as you can. And then you need to connect the dots, add arrows on the end, and in this case, we're going to label it line A because we're actually going to graph all 4 of these on the same coordinate or XY axis. All right, let's look at this next one. I can see here that my coefficient of x is 2 over 3, so that means our slope is 2 over 3. So this slope is telling us to go up 2, right 3. I see also that my b value here is positive 2, which means my y-intercept is 0, 2. Remember, we always write it as a coordinate. So start by plotting your y-intercept and then follow your slope. Up 2, right 3, and that's where our next point will go. Or we can go backwards, down 2, left 3, and that's where our next coordinate goes. And then if we connect the dots, we should again get a nice straight line. Add your arrows and label it line B. Okay, let's look at this next example. I can see that the coefficient of x is 1/2, so that will be our slope, 1/2, telling us to go up 1, right 2. So that's going to be our movement. I can see here that my b value must be 0, so my y-intercept is 0, 0 at the origin. So we always start at the y-intercept and then follow our slope, up 1, right 2. Up 1, right 2. Or backwards, down 1, left 2. Down 1, left 2. From there, just connect the dots. You should have a nice straight line, and we'll label it line C. Okay, last one together. Here you can see that the coefficient of x is 2. However, remember, we're going to write it as a fraction, so 2/1, so we can see the rise and the run. This is telling us to go up 2, right 1. I see that my b value is -1, which means my y-intercept is 0, -1. My b value is -1. Okay, let's start by plotting our y-intercept at 0, -1, and then we'll follow our slope. Up 2, right 1, up 2, right 1, up 2, right 1, or we can move backwards, down 2, left 1, and then connect your dots, and we will label it line D. And we're all done. Okay, go ahead and pause the video and give these 4 a try. Create a new XY axis, but you can graph all 4 on the same one. And please make sure you write the slope and the y-intercept. Okay, let's go ahead and check our answers here. So for part A, you can see our graph is here in blue. The y-intercept is 0, 0, and the slope is 3/1, up 3, right 1. For part B, our y-intercept is 0, -2, and our slope is 1/1, so up 1, right 1. For part C, our y-intercept is at 0, 3, and our slope is 1/3. So we have up 1, right 3, or down 1, left 3. And for part D, our y-intercept is at 0, -3, and our slope is 1/4. So up 1, right 4. Okay, let's try some with negative slopes now together. So as a general rule of thumb, if I ever see a negative slope, I'm going to place the negative sign in the numerator. So I'm going to do this every time just so it's consistent. So if I ask myself, how many x's do I see? Well, I see -1 of them. So my coefficient is -1, which I'm going to write as -1/1. Remember, I am always going to put the negative in the numerator. So since my rise is negative, that's actually telling us to go down 1. But our denominator is still positive, so we still move to the right. So now I'm going down 1, right 1. I also see that my b value is 0, so my y-intercept is 0, 0 at the origin. So we start there, and then we follow the slope. Down 1, right 1, down 1, right 1, or opposite, up 1, left 1. So you can see that this creates a graph that is going downhill because it has a negative slope, and we'll label it line A. All right, let's look at this next example. The coefficient of x, the coefficient is just the number, is -2. So my slope is -2/1. Put the negative in the numerator. This is telling us to go down 2, right 1. Since my b value is 1, that means that my y-intercept is at 0, 1. So I'm going to start with my y-intercept and then follow my slope. Down 2, right 1. Down 2, right 1. Or up 2, left 1. And then connect your dots. It should make a straight line. and we will label it line B. Okay, let's look at this last one. I can see that the coefficient of x is negative 2 over 3. So remember, I'm going to place the negative in the numerator. So this tells us to go down 2, right 3. My b value is negative 1, so my y-intercept is 0, negative 1. So we always start there, and then we follow the slope. Down 2, right 3, or the opposite, which is up 2, left 3. And then when we connect our dots, we should get a nice straight line. And we'll label that line C. All right, go ahead and pause the video and give these 3 problems a try. And notice this is 2 separate equations. They kind of got squished together, but we have y equals negative 2x plus 2, and then y equals negative x minus 1. Okay, go ahead and check your answers here. For part A, our y-intercept is 0, 2, and our slope is negative 2 over 1. For part B, our y-intercept is at 0, negative 1, and our slope is negative 1 over 1. And for part C, our y-intercept is at 0, 3, and our slope is negative 1 over 2. Okay, the last few examples I want to talk about are some special cases. So here, we actually have specific types of lines. So if you look at this first one, we have y equals 4. So let's look at this. Let's compare this with our slope-intercept form, which remember is y equals mx plus b. So you might notice that what's missing is our entire x term. We still have a number, so I can see that b is 4, which gives us a y-intercept of 0, 4. However, you might notice that we're missing this x value completely. So since I don't see any x's, I'm going to say that I have 0 x's, which means my m value is actually 0. So let's think of that as, let's just say 0 over 1. So this means we are not moving up or down, but we're still going to move right or left. So let's graph that and see what happens. What happens if our slope is 0? So here's my y-intercept at 0, 4. So if I don't move up or down, but I just move right 1, right 1, right 1, or left 1, left 1, left 1, what you'll see is that we get a horizontal line. So anytime you just see y equals a number, you are always going to get a horizontal line. You can still find the y-intercept, but your slope is actually 0. And it makes sense because it's just a flat line. It's just like a flat road that has no slant or hill to it. Now we can also look at part C, because you'll see this is also a horizontal line. So for this one, we see that we have a b value, so we have a y-intercept at 0, negative 3, but our slope is 0. So since our slope is 0, we have another horizontal line. So once again, anytime you see y equals a number, if your x term is missing, you're going to have a horizontal line. Now here you actually see that we have no y term. So actually what's happening here is we don't even have slope-intercept form. This is a special type of line. So let's start by finding where on our graph x is equal to negative 2. Let's start plotting some points. So I see x is equal to negative 2 here. But it's also equal to negative 2 here, and here, and here, and here, right? This coordinate is negative 2, 1, negative 2, 2, negative 2, 3. So all of these coordinates have an x value that's negative 2. So if you connect those dots like this, you'll see that we actually get a vertical line. So anytime you only have x, if you just have x equals, we have a vertical line. And vertical lines actually have a really specific slope. Their slope is actually undefined. It's undefined. The slope actually does not exist. If you think about it, that kind of makes sense because, yeah, a flat road just has a slope of 0. You can have a steep line, maybe one that goes like this. You can even have a really flat line with a small slope, but you can never have a slope that is straight up and down. It's actually impossible to define. So we say that this slope is undefined. So these are really the two special types of lines to look out for. So if you ever see just y equals, it's going to be horizontal. And if you ever see just x equals, it's going to be vertical. All right, that is all for today's lesson. Thank you so much for watching.